आई खड़ी है ना।
तो कोई नहीं है अभी तक।
हम्म।
वीडियो तो
अभी आ जाएंगे ना। जब मिलता है फिर वो लेनोवो को भी बनाओ ना। We'll start at 12 o'clock. I welcome Dr. Anamika Yadav for sparing her valuable time for this presentation.
Thank you, Dr. Sachi. Am I audible?
Yeah. Yes.
Okay. So
Actually, last
we'll
session
wait.
has just ended, so participants are taking time to join.
Okay. I will wait. No problem.
Okay, thank you. Admit all. सर ने भी अच्छा So I welcome you all for this presentation by Dr. Anamika Yadav. She is a professor in the Department of Electrical Engineering at National Institute of Technology, Raipur. And she has over 16 years of academic as well as industrial experience. Her main area of interests are power system protection, artificial intelligence applications in power system, load forecasting, and smart grid technologies. She is a senior member IEEE and recipient of multiple national and international awards, including recognition in Stanford Elsevier top 2% scientist list from 2021 to 2024. As well as her academic and industrial experience is concerned, she joined Balco Korba in 2002 as a graduate engineer trainee and then moved on to assistant engineer Chhattisgarh State Power Generation Company Limited from 2004 to 2009. And she joined IIT Raipur as assistant professor in the year 2009 and then promoted as associate professor and professor from 2023. And 2023 to 2025, she acted as a head of the department, NIT Raipur. As far as her education is concerned, she completed her BE from electrical engineering from RGPV Bhopal in 2002 and then MTech in electrical engineering from VNIT Nagpur. She completed her PhD from CSVTU Bhilai and with NIT Raipur as the research center in 2010. So I welcome Dr. Yadav for thank Dr. Yadav for sparing her valuable time and get ready for the giving her valuable experience, sharing her valuable experience with us through her presentation in this field of load forecasting. So I welcome Dr. Yadav.
Thank you, Dr. Sanjay, for the nice introduction. At the outset, I would like to express a sincere gratitude to the organizer of this AICTE-sponsored ATAL Faculty Development Program on Operations and Control of Power System in India. Thank you for inviting me to share my thoughts with the participants of this FDP. It's an important platform and I'm truly honored to be a part of this program, which is graced by the faculty members of Thapar Institute of Engineering and Technology, Patiala, as well as the participants across India. The theme of this FDP is extremely timely as power system in India is undergoing rapid transformation due to increasing integration of renewable energy sources, digital control, and AI-driven decision support. I am very confident that this FDP will provide you the valuable insights and foster collaboration among participants from academia, research, and industry. Thank you. So I will start my presentation. Have you given me the rights to share my screen?
Yes, ma'am. You are co-host now. You can share your screen.
Okay. So screen is visible, it seems. So today I will be covering the important topic on load forecasting techniques for short-term and long-term planning. It will be valuable for the researchers working in this area. Particularly, it is more useful for the electrical utilities and load dispatch centers across India. India is divided into 5 regions, and in this FDP, I would be covering the following topics, starting with introduction to load forecasting, then overview of the Indian electricity grid and the load demand across India and different states. Then what are the different types of forecasting, the factors which affects load forecasting and the challenges encountered for the load forecasting. Then certain solutions which are based on artificial intelligence to develop load forecasting models for load dispatch centers of Indian states, followed by conclusion, few publications and references. So, starting with introduction of load forecasting. So, load forecasting can be defined as estimation of the load demand in advance. It is a technique used by electrical companies or utilities to predict the future energy or power demand that will be needed to maintain equilibrium between the demand and the generation available. Power system expansion planning starts with a forecast of an anticipated load demand, and it also helps to further plan for development of future infrastructure to meet the load demand. On daily basis, it gives you the right decision making for purchasing or selling the power based on surplus or deficit power generation available. And finally, if we are having deficit in the load demand, then we need to shed the loads. So load shedding and price settings, these features can be planned by the power system engineers based on the load demand value forecasted available. In Indian load dispatch centers, particularly, they have directed all regional and state power utilities to collaborate with nearby academician and institution to develop the load forecasting models for them. And in this, I have got a sponsored project from Central Power Research Institute, Bangalore. And in that project, I have developed load forecasting model for Chhattisgarh state and Delhi and Odisha state. So in this presentation, I would be discussing the real-time implementation of load forecasting models using AI-based techniques for using the real data captured or collected from the load dispatch centers of the Indian states. Generally, load forecasting models, they are, let me have one. So generally from place to place, load forecasting model changes because the overall load demand of a particular state, it depends on demographical, geographical locations, the urbanization and industrialization of that particular place, and the overall population and weather changes experienced by that place. So different load forecasting models are required separately at state levels. So in this presentation, I will focus more on real-time estimation of load demand, particularly on every 15 minutes basis, which can be further enhanced for daily, weekly, monthly, or yearly estimation of the load demand for State Load Dispatch Center of Chhattisgarh, Odisha, and Delhi. This is an actual field experience because we have utilized the actual real-time data collected from load dispatch centers of India. And finally, it is being used at Chhattisgarh for load forecasting. So we must know that why there is a need of load forecasting. Load forecasting is essential tool for the power system engineer for planning and operations, particularly to plan the adequate generation capacity. Say, for example, in future, coming 5 years, what will be the load demand for particular state? So we have to plan in advance to develop new power stations to meet out the load demand in future, which may encounter after say 5 years. So that comes under long-term planning. And usually to develop a new power station, particularly say, if I say thermal power station, so it requires around 3 to 4 years to develop that. So adequate planning for generation capacity expansion is required. Similarly, for power evacuation, we require efficient transmission and distribution structures. For that also, load demand estimation in advance is required. And finally, it will give you an economic benefit because that will give you the major decision making for selling or purchasing the power based on the availability of the generation. And also, because of integration of renewable energy sources in the power grid, during daytime, we are having more surplus power as compared to the night hours. So accordingly, we can sell power to the nearby deficit generation areas and finally gain economic benefits. So this slide shows a typical Indian load curve, and it is a variation of the load demand with respect to time in hour. So for a one particular day, this load curve is being plotted. And this curve for particular day, so that curve is known as a daily load curve. And if this curve is plotted on weekly or monthly basis, so accordingly it will named as weekly or monthly load curve. This reflects the activity of the population of India with respect to electrical power consumptions over a given period of time. So you can understand here in this this is the night hours starting from 0 to 4 to 5. After that, you can see the curve gets increasing. So daytime that has come now. So now accordingly the power consumption has been increased, and till morning from say around 6 to 12, the power consumption this is the morning peak. And then after in the afternoon, this is the day lean period. And finally, at the night hours, the evening peak that is experienced in India. The power demand in India is around 135 gigawatt at certain time. The sample shape and width of this magnitude curve varies from state to state and also depends upon customer type. Say, for example, if the type of customer is domestic or agricultural. So agricultural usually they use during day or night hours as compared to the domestic users, which are, you can say, the more power consumption is during night hours. And industrial or commercial, industrial, particularly 24-hour running continuous process industries usually have power consumption throughout the day, and other commercial aspects governs their load consumption pattern. So this slide now shows you the Indian grid that is being separated into 5 regional grid. So I am in Chhattisgarh. So Chhattisgarh comes under western grid, and Patiala comes under northern grid. Then this is the southern grid, and another is eastern grid, and there is another northeastern grid. That is, so overall 5 grids have been made for Indian mainland. Now this slide shows the hourly peak demand that is met in India level in megawatts for different regions. Particularly for the month of October 2023, the maximum and minimum and average value and all-time maximum that has shown for the 5 regional grids. From this, we can see that in the month of October 2023, the maximum load demand experienced by India is 203 gigawatts, and the minimum was 169 gigawatts. Average value experienced is 192 gigawatts, and all-time maximum is 215 gigawatts. So this is in megawatts, so I had converted into gigawatt. This is as per the report published by POSCO in the year 2023-2024. So the demand that is actually consumption made all over India, that is shown in this slide. So you can see that the pattern, particularly for October month of year 2023, is shown in this slide. And all over India, this is the load demand pattern. And this all over India pattern is actually the sum of the 5 regional grid consumptions, and herein the lowermost consumption is done by northeastern, whereas second highest is eastern region, then comes southern region and northern region, and then come the western region. So the daily load demand curve for Indian national grids that is made herein for particular day. That was for, you can say, the average value for one particular month. Now for a particular day, the load demand patterns is looking like this. Why my screen has shifted? This load demand is actually made by different types of fuel based power generation like linear, thermal, hydel, gas, solar, and wind. So overall, my screen is why it is changing again and again. Kindly admit few people, those are coming in between.
Yes, ma'am.
So overall, generally the solar and wind, you can say the graph herein shows the generation that is met by wind is very small as compared to the solar. You can see that this is the time of during the day, light hours, you can say, for the solar energy, and the base load is actually made by thermal, and this is the nuclear, and smaller one, this portion bluish one shows the hydel power. So in day hours, we have a high generation through solar of around 170 gigawatts, whereas during night hours, we need to cater the load demand using the conventional energy sources. For particular a weak pattern experienced by India as the load demand is shown herein, you can see that the pattern for overall load demand for particular days is shown. The value sometimes decreases, sometimes increases, then again it is decreased. So overall pattern is almost same, but the value of the load demand is changing. And also the peak value, sometimes the value point, that is changing. So to estimate the load demand in advance on short-term basis, that is at every 15 minutes, the main task is to capture the temporal dependency of the load demand on various factors. Herein, region-wise installed capacity of India is shown herein. You can see that the all over India, the power generation, particularly through coal, lignite, gas, and diesel, that amounts to 239 gigawatt, whereas through nuclear, hydro, renewable energy sources, in all we have 425 gigawatts available. Now, that was an overview of the overall load demand experienced by India. Now we come towards the type of forecasting methods based on the time horizon. So if we want to estimate the load demand on every 50 minutes up to a week point on daily or hourly basis, or up to a week point, then that is categorized as short-term forecast. Whereas when we want to estimate the load demand for a week to up to an year duration, then it comes under medium forecast. Whereas if we want to predict the load demand over 1 year, more than 1 year also, then that comes under long-term forecast. So there are various factors which affect the load forecasting, particularly the system factors, that is the generation availability and the plant maintenance, sudden outages of generators or oblique lines. This affects the load forecast. Then the time factors, that is the different calendar features, you can say, for which time of the year we are talking, the day of the week or the hour of the day, whether it is an holiday, that too, whether it is national holiday or local holiday, whether there are festivals or events are on that day or not. So time factors governs the load demand. Finally, economic factors like the economic growth, tariff structure, and new load growth of that particular region. You know that tariff structures usually vary in India. It is not fixed all over across the India. Particularly, Chhattisgarh provides you the cheapest electricity, and as compared to Madhya Pradesh, wherein the tariff structure is more. So that factors governs the load demand or the load consumption patterns of the particular region. Then weather factors, temperature, wind, rain, humidity, and solar radiation experienced by that region is important factors on the load demand patterns. Then demographical changes, demand side management and energy efficiency programs, that is, you can say through system level it is. Then integration of renewable and distributed energy sources, and data quality and feature selection. All these factors affects the load demand. Now, what is the challenges in load demand? As load forecasting is based on historical load data and weather information, particularly environmental temperature conditions. So different regions have different weather conditions that are experienced. So accordingly, they will affect the demand pattern of that particular region. The predicted value of the load demand is somewhat different than actual. Obviously, we cannot the prediction may not always overlap as compared to the actual load demand. You can see this is the typical load demand and actual load forecast curve plotted simultaneously to show you the difference in the actual in the forecasted load demand. So it may not be the same every time. So if underestimation of load demand results in, if we underestimate that the load demand is lesser as compared to the actual load demand, in that case, what will happen? The system will experience the supply shortage and force power outage will be there, which will serious consequence on the productivity and economic growth of that particular region. If we overestimate the load demand, so it will lead to over-investment in the generation capacity and possible financial distress and ultimately higher electricity prices. So now comes the objective of forecasting. So for short-term forecasting and long-term forecasting, there will be different objectives. First objective is to support the operational decisions such as unit commitment, economic load dispatch, load balancing, and energy trading. These are basically the main objective for short-term forecasting. Whereas for long-term forecasting, the main objective is to guide the infrastructure development, generation expansion planning, and policy formulation. So there are different forecasting techniques that are available in literature. They can be classified into traditional statistical method based and artificial intelligence based or hybrid models. So I will discuss each one of them in short and then come on to the real-time implementation of AI based models. So under regression models, we have linear and multiple regression models, which gives the relationship between load value and the variables, particularly like temperature, humidity, and day type. So it has advantages that they are simple and fast, and limitation that they cannot capture the non-linear dependency. Then comes time series models, which is ARIMA, SARIMA. So ARIMA is autoregressive or integrated moving average method, which is effective for stationary series with trend and seasonality. And SARIMA extends the ARIMA model to handle the periodic patterns. Then exponential smoothing like Holt winters, they are suitable for short-term prediction with seasonal data. Further, the time series model have limited adaptability to sudden load variations and non-stationary data. Then comes AI-based and machine learning models, particularly artificial neural networks, support vector machines, decision tree-based model, and K-nearest models have been explored in literature to develop load forecasting models. Then comes deep learning based models. Under deep learning, recurrent neural network and long short-term memory networks have been utilized. Similarly, convolution neural network and transformer models and hybrid combinations of them have been explored by scientists and researchers for smart grid forecasting. Then hybrid models and long-term forecasting models are econometric models and use and techno-economic models and certain scenario-based models. Now we will discuss the actual implementation of load forecasting, the steps that should be followed to develop any load forecasting model. So first is the data collection and data preparation. Once the previous at least 4 to 5 years load demand experienced by any particular region, that should be collected from the load dispatch centers of that particular region. Then once the data is available with you, you need to prepare the data. Under preparation of data, we need to arrange and filter the data, apply the data scaling technique, and sometimes some missing values are there. So we need to input those missing value from the previous timestamp values. And if there are certain outliers in the data, we need to remove those outliers. So data preparation and data preprocessing steps are foremost. Then once the data is prepared, we need to split those data into training, testing, and validation data set, which is required for any training based or learning based model based on artificial intelligence. Then once the data is available, now we need to select the particular model that we need to use to forecast the load demand. So in this model designing and simulation, say we need to select different artificial intelligence based model and then compare their performance to select the top performer among them, which gives the least error in estimation of the load demand as compared to the actual load demand. So while developing, we need to train the model and test and validate it with the separate data set which has been splitted. And then finally, save the forecasted load demand. And because we have initially applied data scaling techniques, so we need to denormalize the forecasted load demand and compare it with the true value to get the error matrices. So in this, we have collected the raw data at every 15 minutes interval from the state load dispatch centers, particularly Delhi, Orissa, and Chhattisgarh. And additionally, historical weather data is collected. The range of the data set that has been collected is say from January 2022 till October 2023, as well as last week of December 2021 is also collected. Then data arrangement and filtering techniques. In this, all collected load demand and weather data, they are arranged at every 15 minutes interval. And each interval has 4 data points as 15 minutes interval, particular hour. So for 24 we have 96 data points for one particular day. If there is any missing data points, we need to update it with previous time interval data point. Then to apply the data scaling technique, in using MATLAB software, we can apply the different data scaling techniques. Particularly for the real-time implementation, we have normalized the data points in the range from 0 to 1 using min-max technique, max-min-max technique. Then we have splitted the data set into training and testing data set. During training, we have utilized complete 2022 year data points as well as last week of December 2021. And for testing, we have kept January 2023 to June 2023 data points. And the model, AI-based model that has been chosen is long short-term memory model and artificial neural network model, Gaussian process regression model. These 3 GPR models have been developed using MATLAB software as the building platform. The model parameters are estimated and the training of the network is done using the training data set for year 2022. Then the trained model is used to predict the future load demand for the testing data set as well as any other validation data set. After the trained model predicts, we need to denormalize the forecasted result and compare it with the actual load demand. Using the comparison feature, we can estimate different error matrices like mean absolute error, direct absolute error, then mean absolute percentage error, root mean square error. These are the error matrices which are used to evaluate the performance of the developed model and compare the developed model using these matrices. So this is the flow chart for the AI-based load forecasting schemes. We take the inputs as temperature, wind speed, then hour, weekday, holiday, then previous day or previous week load demand value. Develop AI-based model. We can select any among the available networks like neural network, time series, fuzzy logic, decision tree, LSTM, GPR. Then once the network is developed or trained, it is used as AI-based forecaster, which takes previous load and time and weather factors as input to forecast the load demand. Then finally, a calibration report, which gives you the different error matrices to compare the performance. Now, what is the importance of feature extraction in machine learning technique? Input features plays very important role in machine learning techniques, particularly information representation and impact on model performance. In feature encapsulate the data space and patterns and its relationship with respect to the target value. The model performance gives you the quality features and boosts the accuracy, overall convergence rate during training, and finally the generalization of the model for unforeseen data is done. This is to reduce the overfitting. Further, feature engineering involves transforming and creating the feature vector to enhance the performance and require domain knowledge and creativity. Then dimensionality reduction. Herein, complex data improves the efficiency and achieved through feature selections or principal component analysis. Then model interpretability, wherein certain models offer insights through feature importance, aiding the decision making and handling the missing data or noisy data. Herein, this issue mitigates the data quality. And knowledge domain integration, which incorporates domain specific knowledge and enhances the feature selection, improving the model ability to capture the essential patterns. So in this case, the weather data and historical load data that has been used for forecasting the load demand of the 3 Indian states, Chhattisgarh, Odisha, and Delhi. The main features that we have used is the calendar feature like day of the week, holiday, time of the day, and the seasonal factors. And it accounts the variation of the energy usage under different seasons, and economic indicators like growth development index, population growth, industrial output, they influence the energy demand, and these indicators can be used as an input features to capture the relationship between economic trend and the electricity consumption. Overall load for similar period, for that we can use the previous week same day demand as one of the input feature to identify the patterns on the similar day. And special events or anomalies like holidays or planned outages, they can also affect the overall energy demand, so they can be utilized as a categorical feature for forecasting the load demand. So in this slide shows the load demand for the 3 years for Chhattisgarh, 2021, 2022, and 2023. So in this case, you can see that particularly the corona second wave was in the year 2021, and you can see the load demand patterns that is experienced. This is the actual load demand on every 15 minutes basis. It has been further using the trend, season, and residual matrix that has been calculated for this load demand pattern. And you can see the trend of the load demand is like this, and seasonal variation is having the shape like this, and certain residual factors are given in this. Whereas in the case of year 2022, the seasonal pattern has changed. Also, the trend has been changed. Further, year 2023, the trend is changed. Seasonal pattern is also changed as compared to the previous year. So, directly from the previous year load demand, we cannot forecast the new upcoming year load demand. It is usually dependent on the overall power consumptions of that state on various factors. So first we'll start with load forecasting model for Odisha state using long short-term memory. Herein, every 15 minutes interval load demand data for Odisha state has been gathered for year 2022 and 2023. And we have compared the model performance using 2 other models represented by Gaussian process regression and neural network. So herein, the data has been collected from Tata Power Southern Odisha Distribution Company, and they have provided a data set for 2022 year and for 2023 January only. So 2023 we have taken as test data set, and from complete 2022 has been taken as input for during training data set. Then meteorological features have been collected from Power Data Access Viewer site, and the model has been trained for complete 2022 year, and it has been tested for January 2023. The steps that has been performed are similar as explained previous in like data processing, data gathering, cleaning, visualization, and finding the correlation coefficient. So the input features that we have gathered are block temperature at 2 meter, relative humidity at 2 meter, dew point temperature at 2 meter, wet bulb temperature at 2 meter, wind speed at 10 meter. And the target is the load demand at kth interval, and training interval is complete year 2022, and testing interval is January 2023. So you can see herein that the actual and the predicted load curve and the corresponding error obtained using GPR is shown herein. The actual and the load demand in megawatts is shown in this figure. You can see the load demand for up to 600 megawatt is experienced, and red shows the actual one and the bluish curve shows the forecasted one. And this is the error. The error is in the range of plus minus 50 megawatt usually, and that can be through this curve, or we can also plot a histogram of the load prediction curve, which gives you the frequency, the number of patterns that comes in this error range. So you can see that major patterns come under the range of plus minus 50 megawatts. There are few patterns which are estimated with larger error, but most of the patterns comes under the range of plus minus 50 megawatt using Gaussian process regression. Then we have used the same input for neural network also. So when the model using neural network is trained, the actual and the predicted load curve is forecasted with lesser error as compared to the previous one. Here in the range comes between plus minus 20 megawatt. You can see here in the error range, the frequency of the number of patterns lie in the range of plus minus 20 megawatt mostly, as compared to few which lie in the range greater than that of 20 megawatt. So in this case, the mean absolute percentage error obtained using neural network is 0.2567 megawatt. Now, the same has been, input has been taken through long short-term memory model. This is a deep learning based model which is utilized to capture the temporal dependency on the weather parameter as well as the previous load demand trend, and the same 2022 year has been taken for training, and the January 2023 has been used for testing. So this plot shows for January, it is 2976 data set for 31st up till 31st of March, 31st of January 2023. So you can see that now the load demand value comes in the error range comes between plus minus 10 megawatt, and the overlap in the actual and the forecasted can be seen very clearly because bluish and the red one both overlap each other almost, and the error range has reduced to plus minus 10 megawatt. The error histogram is shown for this. You can see here the maximum patterns lie in the range of plus minus 10 megawatt, whereas few are greater than that of 10 megawatt. So among the three, GPR, neural network, and LSTM outperform all the three models, giving the least error in estimation. The plots that are shown herein are gives you the error range in terms of for one complete month. So now the same plots are being done for say particular day. So from particular day plot, you can check it that the estimated is the bluish curve and actual is the red curve. The load demand curve, actual and forecasted, they almost overlap each other. And if you check about the error value, the error range lie between plus minus 10 mostly. So this is for 96 data point for one particular day, that is for 1st of January. Similarly for 31st of January, this is the plot, and then for 1 week of January, first week of January, we have shown the load demand curve. So it is forecasting in a very accurate way, and that gives you the major advantage of long short-term memory model, which gives you least error. Now, we have trained the model using only year 2022 data set, but we have forecasted the load demand for the future, that is for 16 to 22 March 2023. This paper has been submitted in the year 2023 first week of March. So while submitting, we have predicted the load demand pattern for the coming week, and that is shown here in as the forecasted pattern for 16 to 22 March. Similarly, the forecasted pattern for 15 to 21 June 2023 has been shown in this figure.
Ma'am, if you wish to have 5 minutes break, then we can have a break of 5 minutes and then we can join back.
In between, do you want a break?
No, I miss you are because it's almost 45
right.
minutes since you are speaking. And if you want to have 5 minutes break, then we can.
Okay, do not allow the participants to move, please, because that will create only I will have some water and come back. Okay.
Okay, let's have 2 minutes break.
Okay. Okay, so I will start now.
Okay, okay.
So in this slide now, I'm comparing the models that have been developed for load forecasting of Odisha state. We have seen that the LSTM model is superior as compared to GPR and neural network model in terms of accuracy. Herein, we see further that in GPR, we have varied the kernel functions from exponential to squared exponential and rational quadratic and Matten 5/2. The mean absolute error obtained using different GPR models, neural network models, and LSTM models are shown in this slide. So the minimum value is 5.9 megawatt obtained using LSTM network, the mean absolute error value. And the percentage, if I talk about it, is in decimals, 0.2134%. And root mean square error value is 2.8743 megawatt. So among the three models, we have seen the performance. So you can see from the same data set, we have trained the three models, GPR, neural network, and LSTM, and compared the performance using evaluation matrices. Now, for getting the paper published after doing a particular research, it is important to compare the performance of your scheme with existing literature, which is there. So herein, we have compared the developed model from the reported literatures as per references, and we see that the LSTM model comparison parameters, you can say, how we select. So the collection, the data set from which they have collected. For Indian data set, there are very few researchers who have actually encountered the load dispatch forecasting models. But for foreign countries, there are many more researchers available in literature. Then the main parameter that you can compare is the training data set range, like which for one particular range they have selected. Then whether separate testing data set have been chosen or not, and what are the parameters that has been used for the AI based forecasting model. So you can see that the other reported literature takes more input parameters to predict the load demand. And finally, the evaluation matrices has been shown. So as compared to the other available models in literature, the proposed model gives you the least error performance in terms of MAE, MAPE, and RMSE. So in this way, the model validation through literature comparison is also established. So herein now comes the overall conclusion from the first set of AI-based model for Odisha state. So herein we developed three forecasting model using GPR, neural network, and LSTM. The real-time data set for Odisha state has been collected for year 2022 and 2023. Three models have been assessed, and among three, LSTM outperformed the other two models as well as compared to literature, and it demonstrates the least error, shows superior performance as compared to the other two methods. So in this way, we need to compare. Finally, in conclusion, you need to specify the exact quantitative parameters that has been established, and mention the values of MAPE, MAE, and RMSE value that has been obtained. Now, in this case, we have also filed one patent which is granted and another which is published. So AI-based load forecasting model for load dispatch centers of India with following applicants, and the patent was awarded since year 2022. Another method for system and method for electrical load demand forecasting has been applied by myself along with my research team at NIT Raipur. The applicant in this case is NIT Raipur and CPRI Bangalore under the research project sponsored from CPRI Bangalore. The patent is published in Indian Patent Office, and the publication date is 13th of December 2024. So I will now be discussing about the patent that has been published. In the patent, I have reported three load dispatch centers results: Chhattisgarh, Delhi, and Odisha. And therein, I have shortened the number of inputs. I have taken weather parameter only temperature at 2 degrees Celsius, 2 meters in degrees Celsius, and wind speed at 10 meter in meter per second. These are the weather parameter. Then from historical load demand, I took last week load demand at every 15 minutes interval. So for in a particular day, if we take the 15 minutes interval as load demand pattern, so for an hour we get 4 patterns, and for 24 hours we get 96 data point. So in this case, for training the model, I took 2-year data set, that is 2022 and 2023, and weather parameters for the 3 load dispatch center of Delhi, Odisha, and Chhattisgarh. For 1-year data set, we have 35,040 data points. And when we take different input combinations, wherein from previous day demand, if I want to predict the next day demand, the input matrix size will 1 cross 3540. If I take another input combination as last week demand, so the input size is now 7 cross 3540. And in addition to only weather parameter, if I take temperature and wind speed as another input parameters, so now the input numbers is 9 input variables. So the matrix size during training utilized will be 9 cross 3540. So this will be the arrangement of input data patterns. And if you see how the patterns look like, I have shown in this slide. It also shows the heat map. It also shows the heat map because if the green colors in this case shows the high correlations with the load demand, and red color shows low correlations. So accordingly, we have taken all those patterns for Delhi, Odisha, and Chhattisgarh. The pattern, how it look like, and its heat map is shown in this case. These are the inputs from D-1 to D7, wind speed and temperature, forecasting the next day load demand. Now, another Pearson correlation coefficient calculation is important to see the relationship between input feature and load demand. So this coefficient, if it is near to 1, it is said that the input features are highly correlated with the output or the set target. And we can see that the previous week demand, wind speed and temperature, they are having somewhat correlation with the load demand. Wind speed is having somewhat very less, but still we have taken as one of the input parameter for predicting the load demand. So when we prepare the data set, it looked like this. This is a simple snapshot of the training data set patterns and the testing data set patterns arranged in set of every 15 minutes interval for one particular day. Similar way, complete data set for training and testing has to be prepared. Then once the input and target matrix is prepared, we need to simulate the models which are based on ANN, GPR and LSTM, and then we get a forecasted load demand. So input batch size and the target set for the training and testing models, that is, we need to bifurcate the available data set that we are having with us into 2-part, training and testing. So for testing in this case, I have chosen from 1st January 2023 to 14th of April 2023 as the load demand. So now comes the description about long short-term memory model. This is the diagram shows one LSTM cell. It is a type of a recurrent neural network which is specially designed to address the limitation of the recurrent network, particularly in learning and remembering the long-term dependencies of the sequential data. It was introduced by scientists Hochreiter and Schmidhuber in year 1997. The key strength of LSTM lies on its ability to effectively process and make the predictions based on sequential data, particularly the time series data or the text data. And It composed of cell, and these cell have unique structure which consists of 3 gates: input gate, forget gate, and output gate. So these gates regulates the information flow by deciding the information should be let, which information should let in, which should be forgotten, and which should go output to the next layer. So input layer controls the information that has been stored in the cell. Forget gate manages the information that should be discarded from the cell, and output gate determines the information that should be used to make predictions or passed to the next layer. So LSTM network is more effectively capturing the load demand pattern. Similarly, neural network architectures are there. It also consists of input layer, hidden layer, and output layer, and it looks like this. It usually is a feed-forward neural network trained using backpropagation algorithms. The mostly used is Leavenworth-Marguerite algorithms. The activation functions used in the layers can be different, but in present case, we have used tangent sigmoid as the activation functions in the layer. And GPR, it is a power to full tool, particularly Bayesian's approach, and it relies on Gaussian process, wherein the random variables, particularly any finite number which have a joint Gaussian distribution, and they can define over a distribution function rather than a specific function themselves. And it is characterized by a mean function and covariance function. This covariant function is also known as kernel functions. Different kernel functions are employed for GPR, like boosting or mat function or exponential functions. Now, once the 3 models are developed, we need to analyze the performance using evaluation matrices like MAP, RMSE, and mean absolute error. The formula utilized to calculate the 3 matrices are shown in this slide, where yi represents the forecasted value, and xi represents the original load value, and n is the number of samples in the total time stem. So in this case, we have developed for Odisha, Delhi, and Chhattisgarh, and the results using LSTM, GPR, and ANN network are shown in this figure. You can see that the LSTM networks give the least error as compared to the other two for Delhi, similarly for Odisha, and also for Chhattisgarh. That will be shown in another slide. If I compare the 3 models, so we observe that LSTM model outperforms the other 2 model by providing the forecasting with least mean absolute percentage error, and the actual results this is in form of tabulation. If I want to see the actual and forecasted demand plots, so that are shown in this slide. We have taken complete 1st January 2023 to 14th April 2023 data set herein. So for complete data set, the plots are shown where the blue curve shows the forecasted load and red curve shows the actual, and load demand error. Direct difference of the two is shown is the absolute error. This is for Delhi and this is for Odisha. So the pattern you can see, the load demand is maximum till 6,000 megawatt and the error range is around 500 megawatts. So if it is lesser than as compared to peak value herein, you can say it is less than 10%. So now looking to these plots, we are unable to analyze the performance directly. So we need to zoom those curves for particular day or a week or a 15 days pattern. So herein for 3 networks, LSTM, neural network, and GPR, we have plotted for one particular day. This is the pattern for one particular week, 1st to 7th January. This is the pattern And for 1st January to 15th of January, through LSTM, the model is getting lesser error as compared to the other GPR and neural network. The red one shows the forecasted one, and herein you can see the overlapping among the LSTM as compared to the neural network is more with the actual load demand. Similarly, that was for Delhi. Now this is for Odisha. Same type of analysis for 1 day, 1 week, and 1 quarter for February month have been done. Now, the data set that has been tested, we can also further utilize the network to give you plots for any other month. Say, for example, May and June month of 2023 have been plotted herein, and the actual and the forecasted plots are shown. So it can be seen that the error lies within less than 500 megawatt as compared to the total demand of around 6,000 megawatt. Now, if I talk about the comparison in terms of tabular, so for Delhi, when we take only 1 day, previous day to forecast the next day demand or previous week, and when we add temperature and wind speed, so that time how the performance of the 3 network are shown, LSTM, GPR and neural network. So under LSTM, we get lesser value as compared to that of neural network. Similarly is for Odisha. When we take previous 1 week temperature and wind speed as the input features to predict the load demand, the LSTM model gives you least mean absolute percentage error. So this is for Delhi, Odisha. Now for Chhattisgarh, we have taken another input, that is previous year same day load demand. So we have taken D minus 365 as another input to predict the load demand. So pattern is shown in here in same day previous year as additional input for Chhattisgarh, in addition to previous week and temperature and wind speed. So you can see that this is the training result of Chhattisgarh data set using LSTM model. So the blue and red one are shown as actual and forecasted. So there are few outliers that are there, but still if you talk about the absolute error range, it is around 250 megawatt, less than 500 megawatt. And that was for training. If the results for testing between 1st of January to 31st of October 2023, data points have been plotted in this case, and error range is plotted herein. It is in the range of lesser than 500 for actual tested using LSTM model. The error range is shown in this case. If you talk about error range in percentage or in megawatts, so using LSTM, we get an error range of mean absolute error range of 164.95, and MAP percentage error, when we calculate, it is divided by the true value of the actual load demand. So that's why it comes in decimal value, and root mean square error is 267 megawatt. Now I conclude this. Herein, we have developed artificial intelligence and machine learning based and deep learning models to handle the complex problem of load forecasting for 3 Indian states, Chhattisgarh, Odisha, and Delhi. We have developed the load forecasting model, and further we have AI-based model, which we selected is 3 again, LSTM, ANN, and GPR. Different input feature combinations have been investigated as previous day, previous week as well as temperature and wind speed, then previous week, temperature, wind speed, and previous year demand. Then overall, we saw that the LSTM model gives more accurate result as compared to ANN and GPR. For Odisha, the estimation provides you with mean absolute error of 159.373 megawatt and percentage error of 0.0693. For Delhi, MAPE obtained is 155.67 and MAPE of 0.526%. And for Chhattisgarh, 164.955 is the MAE and 0.991 MAPE. So the collective matrix outcomes confirms that the LSTM model incorporating temperature, wind speed, previous week load demand and load demand of same day of the previous year, it represents the most effective combination for load forecasting. So these are few publication lists which you can refer for your research work to extend. So particularly it has been published in Institution of Engineers, IET, Generation, Transmission and Distribution, another conference, and one was in Bhilai, Chhattisgarh, another was in Maldives, and another was in Raipur. So long-term, short-term planning for each everything, we can have different types of load forecasting models. These are few references that you can refer for carrying out the literature survey. This is my Scopus profile from which you can directly access the particular papers that has been published in this research area. And this is my Scopus Google Scholar profile. You can check out the papers published in the areas of research of your interest. And lastly, I give you the email ID and my website, which you can check out and contact me. Now, I would like to open for any question answer session with the participants.
So, any questions regarding load forecasting? Load forecasting is a very important exercise for power system operations because it is used in almost every algorithm like economic load dispatch, unit commitment, all these and optimal power flow, all these algorithms are based upon the load estimation across 24-hour horizon or 6-hour horizon or 15 minutes interval forecasting. Without this, operation cannot be done. And the second thing is this is also used as input for various price forecasting algorithm. Nowadays, price forecasting has also become important because we have now 3 operational exchanges. Power Exchange of India, Indian Energy Exchange, and another one. And where the electricity is daily traded. So load forecasting is also used as an input for those models as well. So if some participants want to ask certain questions from the ma'am, the session is open for the discussion. One small query is, madam, this data is usually not available and RLDCs are not ready to share the data. Like for Chhattisgarh, that may be available, but in northern India, data sharing is a little bit problem. If somebody want to develop their model, it's not available easily.
Yes, sir. Actually, for Chhattisgarh also, I have signed non-disclosure agreement with them that this will be only used for research purpose.
Yeah.
Then only they got agreed, and also as CPRI was one of the agency involved, which is under Ministry of Power, so they were ready to share that
data. Yes. So if there is no question, then we can wind up.
Yes.
Okay. So on behalf of organizing committee, I want to thank Madam Yadav for sparing her valuable time and sharing her experience in the field of load forecasting. Thank you.
Okay.
Thank you.
Thank you, Dr. Sanjay. And hope all participants have enjoyed and they would like to work in this area. And if any query they have in future, they can contact me.
In future
Thank you.
also we'll be like to conduct various programs related to power system, and then we'll also contact.
Okay, thank you.
Thank you. Thank you.